All right, this is the notes for 11-1, transformations of square root functions. We've already done transformations of different functions so far this year, so it should look familiar to you. But you might need to use Desmos, you will need to use Desmos, so make sure that you can access that on your Chromebook, or like I'll show you on my phone throughout the video. You can still graph from any sort of device just going to desmos.com. So the first thing that we need to talk about is standard form of a square root function. So I wrote it out for you already. Standard form is just f of x is equal to the square root of x, which makes sense because we're talking about square root functions, and obviously this is the square root of x. So transformations are things from this. This is your starting point. This is the basic of a square root function. This is as simple as it can get. Transformations are when we change it. So when we move it from left to right to up to down, reflect, make it, like stretch it or shrink it. All of those things are transformations. So when we add stuff to the function, that's how we know that it's being transformed. So we've got 4 different types of transformations that we're going to talk about. The vertical shift. Vertical means that we're shifting up or down. So wherever the function is, it would just be shifted up or be shifted down. So in the equation, that looks like f of x is equal to the square root of x plus or minus k. So if it's plus k, you have a vertical shift up. If it's minus k, you have a vertical shift down. Okay? And as you notice, it's on the outside of the radical, or on the outside of the square root sign. So make sure you make note of that, because that part is important. Because as you can see, in the horizontal shift, we have f of x. This should be an equal sign. Kind of missed both of my bars there. So f of x is equal to the square root of x plus or minus h. And all of this is underneath the square root sign. So that's how I know that it's a horizontal shift. So if it's plus h, then it shifts to the left, so it's going to go that way. If it's minus h, it's going to shift to the right. And when I say it is going to shift, we'll look at what a function looks like, but you want to look from the vertex, because I'll just sketch it for you real quick. We all know that my drawing skills are not very good, but this standard form, you're going to have your vertex at the origin, or at 0, 0, and then it's going to look something like that. Okay, so when it shifts to the left or to the right, the vertex would obviously move to the left or to the right, and then if it shifts up or down, the vertex moves up or down. Then that leads us to the next type of transformation, which is a reflection. So in a reflection, it would go from up here to down here. It would flip. Okay, so it's going to be reflected across the x-axis. And what it looks like in equation form is this negative sign right here. So a reflection flips the graph, and we know that based on the negative in the front. And then the last transformation that we're going to talk about is a vertical stretch or a vertical compression. That's what makes it wider or more narrow. So that's in an equation. You know that it's a stretch or a compression because there's going to be a number in front of the radical, or in front of the square root. Everything else has been after or within, but with a vertical stretch or compression, you're going to have a number in front of the square root sign. So if it's a whole number, so things like counting numbers, 1, 2, 3, 4, 5, etc., that's going to be a vertical stretch. If it's a fraction, so something like 1/2, 1/3, 2/5, that's going to be a vertical compression. So whole numbers are a stretch, fractions are compressions. Okay, so the first example we're going to do is looking at an equation and then determining what types of transformations are performed from the original, from standard form, from your parent function. So if we have f of x is equal to the square root of x minus 2 plus 3, we've got 2 types of transformations here. This minus 2 is inside the radical, so this tells us that we are going to have a horizontal shift, and since it's minus, it goes to the right 2. And then the plus 3 on the outside says that we're going to have a vertical shift, and since it's positive, it goes up by 3. Okay, so each number means something. It's just something extra. So let's look at a second example. So if we have something like f of x is equal to negative 4 times the square root of x plus 1, and let's do minus 2. Okay, so we have a lot going on here. So this minus sign tells us that it's going to be reflected. Then this number on the outside tells us that we're going to have a vertical stretch or a compression. And since this is a whole number, this is going to be a vertical stretch. The plus 1, since it's underneath the radical or it's inside or under the line, this is going to be a horizontal shift. And since it's positive, that tells us that we're going to go to the left 1. So remember, the horizontal shift is always backwards. Negative is to the right, positive is to the left. And then last but not least, this minus 2 tells us there's going to be a vertical shift. And now this is going to be down 2. So each part of your equation tells you something is happening to your original function. And like I said, it's easiest to tell from the vertex. So that means, like, if we're looking at this one right here, it's going to be reflected. The stretch is kind of hard to graph, so don't worry about the stretch too much on a graph. But if I do a horizontal shift to the left 1 and down 2, that means the vertex would now be over here. Okay, and like I said, we're about to look at it on a graph, but just so you know, you can see it from the equation or from a graph. Okay, so now I'm going to switch over to my phone real quick so I can show you an actual graph. So I already have I didn't even download the app. There is an app if you want to download it, but I just went to Safari and put in Desmos from there. So looking at this graph here, I've already hidden the equation so you can't see it. But in standard form, our vertex would be here at the origin. But now, let me see if the light turns off makes it better or worse. It doesn't really matter. Let's see if I turn up the bright. Nah, I think it'll be okay. I know the lines are kind of hard to see. But, so on here, if we start here at the origin, and then we're transforming the vertex over here, this tells us that this shifts to the right 1, and then down 2. Like I said, I know those lines are hard to see, but maybe if I zoom in a little bit. So you can see that we have a horizontal shift to the right 1 and vertical shift down 2. So this equation would be y equals, or f of x equals, the square root of x minus 1 minus 2, because we have a horizontal shift to the right 1 and then down 2. So let's look at another one. I'll show you a reflection. So if we have a reflection, it's going to be negative. That makes it worse. Hang on. So we have a reflection with that negative sign, and then we add anything that we want with our transformation. So I'm going to take the square root of x. Let's do plus 2, and then to get underneath or outside of the radical, we're going to arrow over, and then let's do minus 1. I'm going to go ahead and hide my equation, zoom out a little bit. So now you can see from the origin, we've shifted to the left 2 and down 1, which matches our equation. Because we have a reflection, we've shifted to the left 2, and down 1, which is shown in our graph. Okay, so it's always easiest to tell from that vertex. So that's your notes for 11-1. You do have an assignment. The assignment is 10 questions, but it goes super quick. And you do have multiple attempts, so please make sure to take those attempts if you need it. And then email me if you have any questions on the assignment, and I'll be happy to help you. Thanks, guys.